surprise! It's the most important season of our lives. No! Bang, bang!
Deadliest Cat. Gold Rush, Parker's Trail. Starts 10th August on Discovery Channel.
Heating a room using a water circulation system under the floor is more efficient than using a radiator. Radiators can only be at one end of a room, while a circulation system distributes heat evenly throughout. Warm water pipes are installed under the floor, beneath a plaster leveling layer, in the grooves of a plastic guide mat laid on the subfloor. Each pipe begins and ends at a distribution manifold. The pipes connect to the manifold and each other with various types of brass fittings. This computer-guided equipment makes the simpler straight ones. It first cuts a piece from a long brass bar, progressively shapes it, bores through it, and cuts threads on it. This machine makes the nuts that connect the fittings to the manifold. The machine cuts a piece from a 6-sided brass bar and shapes it into a nut. Curved or T-shaped fittings require forging prior to machining. The factory cuts the bars into ingots. A conveyor then feeds the ingot into an oven. The high temperature softens the brass to a malleable state. After the ingots exit the oven, they are pressed into a mold by a 400-ton press. When the press releases, the forged fitting heads to a collection bin. Workers then place it on a die and trim off the excess brass with a punch press. The fitting now has its basic shape. The next step is to sandblast it. This cleans the surface in preparation for machining. A vibrating tray now feeds the sandblasted fittings to a robot. A camera records the orientation of each piece, guiding the robot to load it in the correct position. Guided by a computer, the transfer machine finalizes the shape of the fitting. This complex machining process, seen here in super slow motion, takes just a few seconds. The transfer machine also makes the manifold from a larger brass bar. This manifold has 10 connections, so if each room of the home is heated by one circuit, this manifold can control 10 rooms. The transfer machine can perform up to 20 different operations on a single fitting. The underfloor heating pipes have 5 layers. To produce the innermost one, an extruder melts granules of polyethylene, a strong, non-porous type of plastic. It is pushed through a circular die and then cooled rapidly to a solid state. Polyethylene pipe enters a second extruder that applies a layer of glue over the poly. The glue adheres the third layer, aluminum. The pipe moves through a series of forming rollers which gradually wrap an aluminum strip around it. This aluminum layer makes the polyethylene pipe strong. Once the pipe is fully encased, a welding machine fuses the strip's overlapping edges. The pipe now receives another layer of glue. Then the outer surface of polyethylene is applied. The factory makes pipes ranging from 1/2 inch to 3.5 inches in diameter. A steel sleeve is pressed over the end, connecting the pipe to the fitting. To set up the heating system, the installers lay a plastic guide mat on the subfloor and snap the pipe into the mat's grooves. They lay plaster leveling tiles on top of the mat to level the surface, then install the flooring. They connect one end of the pipe to an inlet manifold and the other to an outlet manifold. The inlet sends warm water through the pipe. The outlet receives the returning cold water and sends it to the boiler to be reheated. You regulate water flow and temperature either manually or with a thermostat.
I make money. I make a lot of money.
I've handled over $1 billion